Hello, welcome our channel, the Tech Science. The best news of the month, the Vogelsberger wins the 2020 Buchalter Cosmology Prize of the Simulating in the Fuzzy Universe. The associate professor of the physics says to honor with the college the Philip Moggs for their novel dark matter research. The mark of the Vogelsberger is associate professor of the physics or the MIT. The Mark Vogelberger, an associate professor of the physics at MIT, has received the 2020 Buchalter Cosmology Prize in a collaboration led by the Philip Moggs, a postdoc at Princeton University. They reaches the present a novel simulation of early universe with the theorized ultralight of fuzzy dark matter particle. The Buchalter the prize awarded the researchers third prize on $2,500 for their boundary pushing work in the cosmology. The most astrophysicists agree that the theorized substance called the dark matter make up 84% of the mass of the universe. The scientists can observe the gravitational effect of the matter on the visible universe, but they have yet to detect of the dark matter particle. The prevailing theory of the cold dark matter suggests a slower moving the particle with a roughly 1 lakh times the mass of an electron. But because it has a particle remains exclusive, researchers consider other theorized particles like slightly lighter warm dark matter and ultralight fuzzy dark matter, which has about 1 oscillant 10-27 bohm the mass of electron. Depending on the type of the dark matter on early universe would have taken the shape in very different ways. Vogelsberger on the colleges created the three simulation and early galaxy formation in scenarios with cold, warm and fuzzy dark matter particles. In the cold dark matter simulation, galaxies formed in dense clumps. Conventionally, the warm and fuzzy simulation showed long tail-like filaments of galaxy formation unique to the fuzzy dark matter. The simulations, however, illustrated bands of the formation like the string on the harp. This happens because the fuzzy particles are also incredibly light that they act of more like waves than individual particles. When these waves interact, they either reinforce each other or cancel out, producing the quantum interference patterns of the cosmic shell. The researchers hope that with the strong end of the telescope, perhaps even the upcoming James Webb Space Telescope, we can look far enough into the universe to observe the shape of early galaxy clusters. The dense clumps of the galaxy formation would support the prevailing cold dark matter theory, but if you instead see steroid bands, the universe might should be the fuzzy than we think. The first stimulus was the early universe, the mites that look the dark matter constant ultralight fuzzy particles. There is a difference between the proposing the certain dark matter particles and really looking at how the universe might look the type of the particle, says Vogelsberger. We have provided the first simulation. It's a kid. Thank you for watching. The likes and share and subscribe and bell icon. Goodbye.